we're going to look at the secant theorem and do an example of a problem that's solved using this theorem. So this is one of the theorems relating to circles. So here we have a circle, and here's the center. So remember, a line that goes through a circle, not through the center, that is called a secant. So the part of it inside the circle happens to be called a chord. So what we have are two secants, and they intersect outside the circle. So this sets up the relationship that we can define for this problem. So the secant theorem states if two secants intersect, the product of the lengths of each secant and its external segment are equal. So we're looking only at the lengths that are not dotted. So the length of each secant and its external segment. So we're labeling the secant as from here to here in this case. And so here's the external segment. So let's use some numbers to try to define our problem. So I'm going to use some numbers that will not be to scale. Let's see how this works. So in this case, the unknown portion is the external part of this secant. So the secant would be, if this is 25 and this is 5, we would add those two to say that that's 30. And so the product of 30 with the external part, which is 5, that's for this secant, is equal to the product of, now we have the whole length as we add these together, like we added these two together. I'm going to write that in parentheses. Let's call that x plus 5 times the external segment x. So there's the setup for the problem. The product of the secant and its external length for the secant is equal to this secant and its external length. So this circle is tying these two together, and the fact that they intersect. This gives us a circle property relationship that allows us to define this relationship for which we can solve and find an unknown. So if I continue, if I think of 5 times 3 is 15, and I'll add the 0 onto it. 5 times 30 is 150. Is equal to, now I'll distribute the x to get x squared plus 5x. Now I'm setting up a relationship for a quadratic to solve. So if I move my constant over with my variables, now I've just defined a quadratic. So at this point we're trying to solve the quadratic that we've established. So we want to do it by a technique of factoring a trinomial. That just means there are 3 terms, and we're going to factor it. So we need to look at 150, negative 150, and think of factors of negative 150 that will combine to make 5x. So looks like 150, I can express that as 15 times 10. And for that to be a negative, one of these needs to be negative. To make this a positive 5, I'll make the 10 a negative. So 15 times negative 10 is 150. and 15 minus 10 gives me the 5 that I want. So that looks like this is the right way to factor this. So I've successfully factored my quadratic. So this gives me two solutions. So what plus 15 is 0? This gives me a solution of negative 15, and I get a solution of 10. So for distance, negative doesn't make a lot of sense, so we're going to throw this one out. I'm not going to have a negative 15 length. So it looks like my solution will be 10, and we can check that out and see how that works with our theorem. So we see that if I plug 10 in and see how it works, I expect that to be 150 on this side. So 10 plus 5 is 15 times the exterior part is 10. That gives me the 150. So there's an example of using the secant theorem.